Welcome back. Today we'll be talking about another transformation. This transformation is known as dilation, or we better call it scale. So remember, a few reminders before we begin this transformation. The figure before the transformation is always called the pre-image. We label the pre-image with letters, so for example, triangle ABC. After we apply the transformation, we use the symbol with a little dash. It kind of looks like an apostrophe, but it's aligned straight up and down. And when we read this symbol, we say it's prime. For example, triangle A prime, B prime, C prime. Now let's look at a couple of definitions that are going to help us better understand what a dilation is and how to figure out how to do one. So when applying a dilation to a geometric figure, this will cause the figure to get bigger, or it could cause it to get smaller. Now, the size of the image depends on the scale factor. A scale factor that's greater than 1 will cause the figure to get bigger, and the vertices will be further away from the origin. A scale factor between 0 and 1, or a fraction, will cause the figure to get smaller, and the vertices will become closer to the origin. To determine the new ordered pair, we multiply each ordered pair by the scale factor. So that's how we're going to figure out what a dilation is. We're going to multiply each of the vertices by the scale factor. And then the pre-image and the image are similar. They are not congruent. So we've been talking about other transformations. Other transformations are congruent. However, when we're talking about a dilation, they are not congruent. They're not going to be the same size because we're going to be multiplying by a scale factor. So therefore, they are only similar. The other three transformations, they will be congruent. Dilation is the one that is not, and that is very important to know. Now let's take a look at example A. In example A, it says ABC is dilated by a scale factor of 3. Draw the image of A prime, B prime, C prime. So first thing we're going to need to do is remember from our previous slide how we perform a dilation. And it said we multiply by the scale factor. In this case, our scale factor is 3, so we're going to be multiplying every of the vertices by 3. However, we need to know what the vertices are in order to do that. So let's take a look at our graph here, and we see that A is at positive 3, 0. We see B is at 1, negative 3. And we see C is at negative 2, 2. So now, as we talked about, we're going to multiply each of the points by the scale factor. So I'm going to put times 3 for A, times 3 for B, and times 3 for C. So now I'm going to perform the dilation. So 3 times 3 is 9. 3 times 0 is 0, so I end up with 9, 0. 1 times 3 is 3. Negative 3 times 3 is negative 9. Negative 2 times 3 is negative 6. 2 times 3 is positive 6. So now I've got my points. So now that I've performed my dilation, I'm going to plot my points on the graph, and then I'm going to draw some straight lines to connect them all, making sure that because my scale factor was larger than 1, my figure should get larger, and the vertices should be further away from 0. So while I'm doing that, I need to make sure that my points are actually getting further away from the origin. Otherwise, I probably didn't do the transformation correctly. So I'm going to go to positive 3 down to negative 9. I'm going to go over to negative 6 and up to positive 6. And it looks like from where my points stand, each of them is significantly further away from the origin than the originals. So I'm going to label them A prime, B prime, C prime, and I'm going to bring in my straight lines to connect them to make sure I've got myself a triangle here. And it looks like I do. Remember, when you make your triangle, to use a straight edge or a ruler in order to make yours look like mine. Once you've got your triangle drawn, let's go on to the next one. Here we are at example B, and it says FGH is dilated by a scale factor of 1/2. Draw the image of F prime, G prime, H prime. So again, we've got to take a look at our figure. It's already there on our coordinate plane for us, and we're going to be multiplying by a scale factor of 1/2 because, again, multiplying is how we perform dilations. So before we can do that, we need our original points. So I'm going to take a look at my graph. I've got F at negative 8, positive 4. I've got G at negative 6, positive 10, and I've got H at negative 2, positive 6. So there are my original points. Now, again, I'm going to be multiplying, so I'm going to multiply by the scale factor, and this time our scale factor is 1/2. It's a fraction. We don't need to panic about fractions. Fractions can be our friends. So we're going to multiply each of these by 1/2. Now, if I don't know how to multiply by half, I can use my calculator, divide the top by the bottom, divide the numerator by the denominator, give myself a decimal, and then multiply each of the numbers. So negative 8 times 1/2 and negative 4 times 1/2 is going to give me negative 4, 2. Negative 6 and 10 times 1/2 is going to be negative 3 and positive 5. And negative 2 times 1/2 and positive 6 times 1/2 is going to give me negative 1, 3. So there again, I've got all of my points. I've performed my dilation. And again, since I'm multiplying by a scale factor that's less than 1, or a fraction, my points should get smaller, and they should get closer in on the origin. So let's just make sure that my shape did that. So I've got negative 4, positive 2. So negative 4, positive 2. I'm going to place my point there. And I'm going to call that f prime. Then I'm going to multiply, or I'm going to get negative 3, 5. Just going to plot negative 3, positive 5. And I'm going to call that G prime. And I'm going to take my H, and I'm going to put that at negative 1, positive 3. And I'm going to call that H prime. Now it looks like I've made myself a triangle, so I'm good there. Let's make sure that my triangle's gotten smaller. It looks like it. So I'm going to use my straight edges here to connect my points to make myself a nice little triangle. Use a straight edge or a ruler to make yours. And it looks like I've done it. It's closer to the origin. It's smaller. Everything looks like it's checking out. So we're doing a great job. And the last thing we want to remember is that our shape is going to be similar, not congruent. So although it looks like a triangle that's in the same kind of pattern as this triangle above, it is definitely smaller, so I know that my dilation worked. Let's go on to the next one. Let's take a look at practice number 1. TUV is dilated by a scale factor of 2. Give the coordinates of each vertex. So this is a practice problem. I want you to try it on your own. You're going to go ahead and pause the video, then press play again to see if you're right. Make sure that you're recording each of the vertices and drawing it on your coordinate plane. Go ahead and pause now, try it on your own, and press play again to see if you are right. How did you do? Take a look at your answers, compare them to mine, make sure that your answers match mine, and that your shape looks to be on the same place of the coordinate plane as mine before moving on. Let's go on to the next one. Now taking a look at practice number 2, it tells us that ABC is dilated by a scale factor of 1/3. Give the coordinates of each vertex. Again, this is practice, but notice that you're multiplying by a scale factor that is less than 1. So make sure that you're being very careful with that. So go ahead and pause the video now, press play again to see if you are right. How did you do? Is your points exactly where my points are? Does your triangle look exactly like my triangle? Notice again that you were multiplying by a scale factor that is less than 1, so your shape should have gotten smaller and closer to the origin, which ours did. If you've got yours right, go ahead and move on to the next one. Let's take a look at example C. In example C, it says a rhombus ABCD has the vertices that are listed below, and the rhombus is dilated by a scale factor of 2. What is the coordinates of the image A prime, B prime, C prime, D prime? So notice I don't have my shape on my coordinate plane this time, but that's not a big deal with dilations because all I'm going to be doing is multiplying. They've actually made it easier for us by just lifting the points right there, so we can just multiply each one and get our points. So negative 2 times 2 is going to give us negative 4. 1 times 2 is going to give me positive 2. Same thing with B. 3 times 2 is 6. 2 times 2 is 4. C prime, I've got 4 times 2 is 8. Negative 3 times 2 is negative 6. And for D, I've got negative 1, which is going to be negative 2, and negative 4 times 2 is negative 8. So I've got my points there, so I can just plot those on my coordinate plane, draw my lines, and I should have my shape. Now, the only way to really check this is to plot the original points and then to make sure that our shape has gotten bigger and further away from the origin, or to check our multiplication with a calculator. Both those methods will work if you're looking to see if your answer is correct. But for now, let's just make sure that our points are on the graph and making a rhombus. So we've got negative 4, 2, and that's going to be our A prime. We've got 6, positive 4, That's going to be our b prime. We've got c prime at 8, negative 6. There we go. And we've got d prime at negative 2, negative 8. So we've got our points negative 2, negative 8. Looks like we made ourselves a nice little rhombus. So let's go ahead and take out our straight edge or ruler and connect all of our points together. And you can see that we made our rhombus very nicely. Go ahead and make sure that your answers match mine before moving on to the next one. Finally, we come to practice number 3, where we're talking about quadrilateral JKLM. It has the vertices listed below. This time the rhombus is going to be dilated by a scale factor of 1/4. And we're going to list our coordinates below on the coordinate plane and list down our vertices. So I want you to go ahead and pause the video now, try that one on your own, then press play again to see if you are right. Alright, how did you do? Did your points end up where my points are? Is your shape in the same place as my shape? If it is, good job. If not, go ahead and check to see where you went wrong. You should have been multiplying every single one by 1/4. If you weren't a big fan of fractions, you could always divide 1 by 4 in your calculator, get 0.25, and multiply them that way to make sure that you got the correct answers. This brings us to the end of our video. If you like this video, go ahead and throw us a thumbs up. If you love this video, throw us a sub.